Here we go with some SAT prep questions. And one of the things that I'm asking my geometry students to do, and I think it's a good idea for all students as they're working through their high school math courses, is to stay up to date on SAT questions that are going to be utilizing some of the content pieces that you're learning, and also just to practice the format and practice the types of questions you're going to see. There's no harm in doing lots of practice to get ready for your SATs when you get ready to take them. So I picked 3 questions here, and we are going to go through them together and see what happens with these. Some good things to remember. My geometry class a little while ago was working on central and inscribed angles, and that is what we see happening with this particular question right here. We'll call it question number 1. It's not labeled yet, but we can label it. And this inscribed angle right here is only going to be an inscribed angle if I extend this radius and actually make it a diameter of this circle. So I'm going to go ahead and extend BP and create an intersection point right here. So now what we have with AB, we'll label this M. Okay, is going to be an inscribed angle, and the arc length here for AM is going to be twice the inscribed angle. Remember that? That inscribed angle is going to be half of the intercepted arc. So that's going to help us with that piece. And then I'm going to actually switch up colors here, and we are going to kind of do the same idea with this angle that we have at AC into P at the center, and we're going to extend CP and create an intersection out here. We'll call it N. And that creates an arc length for this inscribed angle of 20, and again it's going to be twice as big, so that arc length is going to be 40 degrees. Now, how is that going to help us out? Well, it looks like now we are going to be using some vertical angles, and we've used these a lot in geometry. So vertical angles are created when lines intersect and you have these equivalent angles on either side of that intersection. For example, if this was 10 degrees, this would also be 10 degrees. That would just be an example. So now I see those vertical angles happening here for us, and if we intersect those angles between NC and MB, we can see that the angle here, which is actually going to be 40 plus 40, is going to be equivalent to the arc length or angle on this side between B to C, which then is going to make that 80 degrees. And that's helpful because the goal here is to find the value of x. What is that value of x going to be? And the value of x is actually a central angle. It's an angle that is centered at the circle. And because it is a central angle, that value of x is going to be equivalent to the arc that it intercepts. So if the arc it intercepts is 80, then x must be equal to 80 degrees. And you're done with that one. Hooray! Got lots of colors going on that particular problem. I like that. All right, here, let's try number 2. We're going to stick with green. And here is our next SAT question. On the line PS above, PQ is equal to RS. I'm going to go ahead and indicate that just real quick so I can keep that in mind. We want to find out the total length from P all the way down here to the value of S. And it looks like because I have equivalent segment lengths between PQ and RS that I could set up an equation. So we're just going to make that happen. X minus 1 is equal to 3x minus 7. And we're going to do a little algebra here. I'm going to add 7 to both sides. Okay, we get x plus 6 is equal to 3x. I'm going to subtract that x from both sides of my equation. We get 6 is equal to 3x minus 1x is going to be 2x, and then dividing by 2. And a lot of these steps you guys might show, and some of them you might do with mental math, and that's totally great, totally fine. We get a value of x is equal to 3. So the tricky part here is not to choose 3 as your answer, if that is a choice, because that really doesn't answer our question. We want to go back and find the length of PS. So I'm going to substitute a 3 back in for my x value here. This is going to be 3 minus 1, and 3 minus 1 is going to be 2, so that's going to be the length of PQ. And then as I substitute a 3 in here, it should also be 2, because remember these segments were equal. Let's see, 9 minus 7, yes, that is 2 as well. And as we add these together, we get a length of PS equal to 2 plus 3 plus 2, or 7. So that is the answer that you would want to select from your multiple choice answers for your SAT. Okay, we're doing great. Let's move on. This is the final question for our SAT video. Call it question number 3. And completing the square is always challenging. If you remember, the equation of our circle is x minus h squared plus y minus k squared is equal to our radius squared. So we're going to make this equation look like that. And we're going to do that by completing the square. That will help us to identify the center of the circle, because you'll remember that the center of our circle is going to be based on your HK values, and the radius of your circle, not that we need it for this problem, but it's good to know, is going to be based on your R values. So we'll identify all of those and then select the right answer. So here we go. Let's get that x squared and the 20x in place, group our x's together, and I'm going to leave some space for completing the square here. And we're going to group our y's together, y squared plus 16y. And again, I'm going to leave a little space, and negative 20 is what everything is equal to here. Okay, so a lot of models for completing the square. The idea of perhaps completing the square in this way with your area model with x squared here and half of 20x in each of these boxes, that is a nice way to get going with completing the square. That way you kind of know what your factors might be. And because this is going to need to be a 10 and this is going to need to be a 10, then what you're going to be adding to complete the square is 100. Some people just take half of your b value. So here's your b value. If you take half of it, 20 divided by 2, and then we square that b value. That's another way to get the number we're going to add. So I'm going to add 100 here, and if I add 100 to this side of my equation, I'm also going to have to add 100 to the other side to keep it balanced. And then kind of the same thing. I'm just going to do this one a little quicker with some mental math over here. Half of 16 is 8. 8 squared is 64. 64 is what I'm going to be adding to both sides of my equation. Okay, so I'm going to go ahead and clean this up a little bit since you guys got to see that happen. And what this means then is that this trinomial can be written as x plus 10 times x plus 10. And this trinomial can be written as y plus 8 times y plus 8. So we have completed the square. And it's equal to, it's going to be 144 over here, but I'm not going to write it in quite yet. So here is our general form of the equation for a circle by completing the square. We have y plus 8 squared is equal to 144. That's what you get when you add together 100 plus 64 and then subtract your 20. So that is a nice handy number to have because 144 is a perfect square. So when we compare this to the general form of your circle, what we now know is that your h value is equal to negative 10, your k value is equal to a negative 8, and your r value, your circle, would be 12 because 12 squared is equal to 144. So that means, to answer our question For this SAT problem, the center of the circle would be located at -10, -8, and we would select choice B. There we go. We did it. Have a good day, guys. Take care.